Hi children, welcome to Eclit Learning. So this is the grade 9 workbook activity playlist. So if you haven't watched my previous videos, there are separate videos for each grade for the textbook and for the workbook. And for this grade 9 chapter 4, there is a textbook video as well. So please watch that video first and try to do these activities in the workbook by yourself and then only come back and watch the video, because don't just copy the answers directly from the workbook video, because that's not going to do any good for you, right? Okay. So today we are going to talk about use of microcontrollers. In activity 4.1, they're asking to make a list of equipments in everyday use that can collect data from sensors and controlled by a microcontroller. So they have given two examples. One thing is like to detect whether people or animals are entering to a farm, or the elephants are entering to villages. So these two things have been written. So you can write a few things like solar power street lamps, where it will automatically, those devices will detect whether there is sunlight or not. So based on that, these street lamps will be switch on, right? And home burglary alarm systems, where it will detect whether any thieves have been entering to your garden and the house. And there are smart refrigerators which will help you in different ways, like to control temperatures and all. Fire detection and safety devices, especially in hotels and public places, you can see this, where it will detect any smoke or fire, and will uh, put the alarms, right? And automated washing machines, which will be fully automatically will be controlling everything, the water levels and everything. And another one is the modern vehicles, right? For example, if it's raining, they will automatically switch on the wipers, right? If it's dark, it will switch off the headlights. So those kind of modern vehicles are also there, right? Next thing is activity 4.2. Make a list of advantages of using microcontrollers. So I have written few which I have took from in the internet. So you also can go and search in the internet and write few advantages. For example, it's a very specific task on will be performed by the microcontroller. So it will take very low time. The execution speed will be more when it is performing an operation, and it's easy to use and for the troubleshooting, right? Because it's only achieving one specific objective. And human efforts also can be saved, and cost and the size of the system is low, right? Those kind of things you can easily write, right? Next thing, actually 4.3, connect to microbit module to the computer and use the block editor to code the following items using what they're asking you to do. When a new project is obtained, the following two blocks are displayed. Yes, on start and forever. We also know that. Get show string and from the basic and connect it to on start and change it to Sri Lanka. So they're asking you to do this. So please check your book separately. I will get it the only the uh, practical part here. So you can refer the textbook by yourself. Okay, so we'll go for the new project. I will give some like demo 4.9, sorry, for grade 9, fourth chapter, something like this, right? So you have two blocks as in the textbook is mentioning you, right? So we have on start and forever. So they are asking you to go for the basic section and get the show string and put it to the on start thing. So we'll move this bit here. And they're asking to change this to Sri Lanka, right? Then they're asking to get a pose from the basic like this and put it down here with 2000 milliseconds, right? And they're asking you to again get show number from this basic section and asking you to put it as 1, right? And they're asking you to take show icon and put it under the forever thing. And they're asking you to change that symbol into this. Yes. So they're actually asking you to download this code and connecting your microbit module and observe. But for now, we'll just see how this is going to work. Now you can see in here, we'll play it and see. Now see Sri Lanka will be shown, right? Full thing. And it will pause for some time and will show number 1. And forever, it will show this. It's not going to stop it, right? So this is the forever block, right? So very easy, not very hard, right? So we'll go for the experiment 2. So I will again, yeah, so we have to take show string, and they're asking you to add some string. Right? And they're asking you to get on button A pressed in the input section. In the input section, you have these inputs, right? And into that, we'll get show number thing here, right? When A is pressed, you will show something. So what you are going to show, you are going to show the temperature value. Like this. So get the temperature from the input menu and include it in the show menu. Get on pressed thing, and now we are going to take another block like this, and we are going to change it into B, right? And again we are showing a number, right? This time it's the compass reading like this. Now again another input where both A and B together you are going to press, right? And you clear the screen. Okay, so basically this is how it will look. So on start, okay, then you have the button A press, button B press, and button A plus B pressing, right? Okay, we'll stop it and we'll do and see. Now first it will show this huge string, temperature, and the compass. Yeah, then when I click the button A, it will show the current temperature. So these are not the real values because we don't have sensors and all. But if you have the real microbit, it will show the temperature of the environment. So this one we can just adjust accordingly and see whether that works. That's it. Okay. So for example, if I make it to 16 Celsius and if I press button A, it will show 16. And if I press button B, it will show the compass heading, right? So from here like this, you can change this and it will show that particular value. And if I press A and B together, now in the real equipment, we can do it like with our 2 hands. But as this is like a simulation happening here, so we can have A plus B as a separate button here. So if I press it, it will clear the full screen. Right? So that is how it will work. Okay, I think it's very clear, not very hard. Activity 4.4. Entering data into microcontroller chip in Arduino board. The Arduino board must be connected to the computer as shown. Enter the program constructed using the Arduino programming language into the microcontroller chip of the Arduino board. Right. So here they're asking you to use the Arduino programming language, which is open source software. And what is open source means like it's not a proprietary one. You don't have to pay anything like proprietary software. It's free and open source, so you can just download it and use it, right? And if you get this Arduino board thing, you can use a cable and you can connect it using these USB ports, right? Okay, so software used to program the microcontroller chip in the Arduino board. So what is the software we are using? It's the usually Arduino software. So this can be downloaded and you can install in the machine and do, right? So this is the best way to do it. That means you have the Arduino board with you and you have the Arduino software installed in your machine. So you do the program, you connect to your computer and do you practically do with the real Arduino board. But if you don't have it, just don't worry. Like best way is this way. But if you don't have it, at least try with some online software and see like a simulation tool and see whether your program is correct or wrong. Right. So for that we can use this Tinkercad, which will help you to do this simulation thing. Right, we'll see this how it will work. Before that, let me show this program. Now in Arduino programming, we need to know there are two methods, right? So setup and the loop. So usually setup will have the code which will like initializing, like it will run only one time. But if it's loop, it will repeatedly will happen, right? Okay, yeah. We'll try this with our Tinkercad. Okay, so basically I go for that site, tinkercad.com. And then what I do is like I will log in with my Google account. So you can either create your account, so whatever you want, or you can use your Google account and log in. So yeah, anyway, you have to log into the system. And then you can go for these designs. And here I have like 3D design circuits. So these are few circuits I have already done. But you can have the way you want. Anyway, you have to go for the new and you have to go for circuits, right? So please refer your textbook with you. I'm just sharing this screen because you refer the textbook and do. We are doing activity 4.5. So connect the Arduino board with the peripherals as shown. So the first, if you have the real board, you take the board and you connect your LED bulb to this particular pins and do, right? This is what I do it in the software way, like simulations, right? So you have to take the Arduino board from here, right? And they're asking you to take the LED bulb, right? And usually if you have the real board, what you will do is you will take the LED bulb and just plug it to the board. But in this software, we basically have to use kind of wires kind of like this. Okay. So it will have the ground and they're asking you to connect to the ground and for the 13th pin. So this one will make it like red from this kind of like this. Okay. So then what they're asking you to do. So they are telling this is USB port which is connected to the computer, right? So if you have the real device, you can do it. And then you have to take we'll move it bit aside here, right? Then they're asking you to take the PIR sensor, right? Like this, okay? And you have to connect it as it is. So in the PRI sensor, we have the, so this is a ground one. So ground we should connect it to the ground like this. So we'll keep it as it's green. So if you double click it, you can change it on the line. Double click it like this. So that's the ground. And next thing is like this VCC means power. Right? Power means this one. So this should connect it to the 5 watt. It's in should be ready as in your book, right? So check these lines. It's a bit different than your textbook. Okay, like this. Okay. And then comes the orange one is the out, right? So they're telling out should be connected to the pin 9. Out is this one signal. So it should be connected to the 9th pin and we'll make it as orange. No. Something like this. Okay, so this is what they're asking you to do. And then they have given you the program. Right, so here you can have this block kind of thing as well as the text way as well, right? So as I told you earlier in the C++ code, we have the setup one and the loop, right? So this is the basic code, right? So here in the setup section, we have this pin modes. So in your textbook, actually in Sinhala one and this one has small difference. In English, they have told to take the 8th, 9th pin. So I will make this change. In the Sinhala one, it's in the 8th pin, right? They're asking you to take like that. The output pin is bit different in Sinhala and English books, right? So here it's a 9. So, but in your textbook, it's just showing pin mode is 8, right? So you have to change either circuit or the code, at least one. In English, in single book, it's 8 in both places, but in English, there's a small printing mistake, right? Okay, so basically what we get it is like, so for this board, this will be the input, right? So from this sensor, you get some signal and you send it as the input. And from the pin 13, we'll give the output for this LED bulb. That's what happens here, right? So basically what happens is first you read it, right? From this, now this is sensor, right? Hope you remember about this particular PIR sensor, what happens, right? So in the PIR sensor, it reads the signal and take that value. And if it is 1, you make this output high. That means this bulb will be switching on. But if there's no any reading, then it will be low. So the bulb will not have any light. Okay. So it happens like this. So if I have to make it a start simulation, let me make it a bit small. So yeah. So if I do any movements here in this censored area, you can see the LEDs light up, right? But if I do any movements here, it doesn't show anything. See, the light is not lit up. So This is a PIR sense. It will detect the movements kind of, right? So here if I do any movements, yes, the LED bulb will have some output. That's what basically happens here. I hope it's very clear and very easy thing, right? So even though you don't have the real equipments with you, you can nicely code it and understand what really happens there, right? Okay. We'll go for the activity 4.6 as well. So connect the Arduino board with the ultrasound wave sensor. Now we are going for another sensor. And they have given you how to do this uh, connecting thing. We'll try it and see. Okay, we'll take the Arduino Uno board. Right. Then we have to take this ultrasound wave sensor. So here it's only having 3 pins, I think. Can you see? Yeah. So not that one. You have to go for the all section and take it. This one. Whole thing. Right? Because this one. Ground pin. So here also we have few pins. So ground pin should be connected to the ground port. So we'll make it kind of black. Yes. Like this. And then they are telling trigger pin should be connected to the second pin of the digital section. So trigger is this one, right? So trigger pin should be connected to the second pin. Second one. So this one will make it like blue. So will be better, yes. Something like this. Yeah, we'll make it bit like this. Okay, it's better. Then they're asking you to get the echo pin for the fourth pin. Echo means this one should be for the fourth pin. So we'll make the color change like green, right? So yeah, like this. Okay. Uh, then they are telling VCC pin in the board is connected to 5 watt. That means this one, it should be connected to the 5 watt. So we'll make it red. Okay, it's something like this. And yes, we have to connect the LED bulb as well, right? So we'll take the LED bulb, like the earlier one, for the 13. For the ground and for the 13th pin. So we'll make this as green, something like this. Okay. And yes, they have asked you to do the program as well. So I took the code, right? So here basically you have setup method again and the loop method. So in the setup, it's initializing stuff. So it's the serial begin, and then you have the outputs, two outputs. Now output for this, right? For the Arduino board. So 13 will give output, and from pin 2, which is giving output from this, right? But it will be an input for the sensor, right? So from the pin 2, they are telling it's output from the Arduino board, but here it's the trigger. So hope you know in the trigger is the input for the sensor. But 4 is the input for the Arduino board. Can you see it's connected to the echo in the sensor? So echo is the output from this sensor, but it will taken as the input for the Arduino board. That's why 4 is the input. Right? So don't get confused with the input output where it is. For the program, it's the Arduino board. Right? So in the sensor, echo means output, trigger is the input. Right? So then there's the loop method. So you take two variables, duration and distance. And initially, it gives two for the two port as high. So this is the output, and it will be taken as the input for the sensor, right? And it delays some time. Again, it give a low uh, output from the Arduino board. So it will be taken as the input for the sensor, right? Then they do some calculation based on the duration and the distance. And if the distance is less than 10, then only this LED bulb will be light up. So actually distance means here with the duration, they do some mathematical operation and then only consider, right? So if it is, if the distance is more than 10, then it will switch off the light. So you can see in some scenarios, this will light up because if it is identified as an obstacle, then only it will light up, right? It's based on the distance and the duration as well, not only distance. Quickly what happens? If it's quickly coming near, then only it will light up. Yeah, so that's the end of chapter 4 workbook activity. So hope you learn a lot of things in this one. So if you haven't still subscribed my channel, please do subscribe the channel. And if you have anything like if you don't understand, if you want some improvements, or if you got good marks, please share them as a comment because that is so encouraging. Yeah, thank you very much.